Okay, I'll keep this quick. This is in discussion to the ongoing discussion about the Leo constellation, about how a part of the Milky Way can be deployed to solve and mitigate the problem statement which the planet Earth is undergoing right now. And in the New World Order, we need new statements, we need new equations, we need new understanding of anything and everything, and particularly from the viewpoint of understanding the um, best of the best in terms of entropy and just embracing the good chaos to encompass and interpolate stuff with the real world data with the consent. And when we talk about consent form is not about the healthcare sector. I'm talking about the consent of the candidate. The candidate needs to know in an OPD document that OPD itself stands for one page document. The clarity has to be there as to what the candidate is supposed to do and what should be the outcome in terms of when the input data itself is whatever the data set is which is being utilized to solve any kind of problem, it's able to cater and interpolate in real time. So I'll just talk about the tagging part because the classification itself is very helpful. Probably I'm thinking today I want to deep dive into the CPCs also and identify a few of the important CPCs which can be utilized to resolve the new world order in a fast, speedy fashion. So for the inspection of image, I have to take this call. Okay, we are going to restart now. When we are trying to understand augmented reality, virtual reality from the aspect of understanding as to how the pixels are taken at the back end with the sensor and deploying the different modules, it becomes very important to understand the quality aspect. So, the two words which are very important are quality and quantity. Quality itself is a better terminology in terms of quality comes at a luxurious price, and there is a reason for that, um, which can be dependent on multiple parameters. And perhaps when we talk about image quality inspection, it is under G060 2207 slash 30168. Then the training and the learning purpose is under G060 2207 slash 2008 1. So, color itself has different hues, and color is, or color understanding can be around. So, we have filters, every filter comes with their color coded stuff, and with every filter, what is perceived through the iris is really different. That is under the color image itself is under G060 2207 slash 102.4. And then how you are able to determine the characteristics of the color hue, it is under G067 slash 90. Segmentation, which includes edge detection involving threshold. Interpolation is important. You should know your non negotiables, and that should be very clear in the OPDs. Um, at the other end of the spectrum, we have back propagation, which is using a gradient descent. That is G06N3 slash 084. Then we have how you're able to inspect the images or the pixel, perhaps, for the detection of the flaw in the image, if any. In terms of this, can be deployed for identifying what is real, what is fake, what is misinformation, which is one of the pressing problem statements after the cybersecurity threats. That is G067 slash 0002. So let's deep dive into, okay, language. Uh huh. Okay. We are, we are going to talk about a neural network here. So let's deep dive into this. I will take a few minutes before we disclose this part. Okay. How is the image captured by any of the handheld devices? So in this particular case, so there's something called, if I have to talk about the terminologies, one is image capturing. Another very relevant term or words, not term, it's a tagline kind of stuff, is image acquisition. Um, what is done at the back end by the sensors and the modules is you're capturing a digital image of the wallpaper to be inspected. Wallpaper could be perhaps, just let's take it as a hypothesis to understand the events and the probabilities and the possibilities. Next is the pre-processing, which is RGB processing, which is capturing the image with an RGB color function to obtain a pre-processed image. Now, we talked about pixel a while ago. We need to test this. We need to test the pixel ratio test, which is computing the proportion of the pixels where the gray value is below a predefined pixel threshold. And if the proportion is greater than the set threshold, we are deploying a determination step, and it goes to another step altogether. And if the proportion is less than the set threshold, the output is there is no defect and it goes to an end. So this is a flow chart where there's a start and there's a stop in the spectrum. Next we have OTSU defect segmentation. Give me a moment. This is OTSU. So OTSU is an algorithm proposed by researchers. So like I also have an algorithm. So I'm also a researcher in many ways, or rather say a researcher plus engineer plus a lot of stuff. Anyhow, OTSO method is a name which is derived from the Japanese researcher who proposed the algorithm at the first place. His name is Nobuyuki OTSO Utsu. I think Utsu would be the correct pronunciation. Okay, let's get back here and we'll try and understand this. Okay, so we are applying the automate, like even the custody algorithm, if you deploy it for any of the use case studies, you'll be able to resolve a couple of things at hands. Which one? I think, yeah, this will work. Okay. The Y itself will suffice. Okay, fine. Just give me a moment, I'll restart.
मैडम सी टाइप में बी टाइप में बोला है
This is C. The other one, ऐसा वाला.
बी टाइप
B is not here.
ये आपका कौन सा है?
This is iPhone.
आईफोन का तो नहीं है, दूसरा नहीं है आपके पास
No.
बी टाइप.
Okay, we are discussing about the OTSO automated threshold algorithm, which can be deployed to a pre-processed image to segment the defective regions. And what is extracted is the way it is evaluated is determining the grayscale features and the geometric features. Then we have GABP classification. I'll try and deep dive into this. So GABP classification, rather, I'll just propose this here. Okay. So when we talk about neural networks, there are zillion neural networks which are already established. And this one is Genetic-Algorithm-optimised Back-Propagation neural network classification. And how it really works is you select the inputs. Okay, add a question answer sticker, yeah. Okay, my favorite contouring. Honestly, is an isosceles triangle, and that is at some point of the day. At the other end is always circular because I'm always trying to figure out the circular economy. So yes, so it will be isosceles triangle at one end of the spectrum. At the another end of the spectrum, it is circle. Okay, so we are talking about the neural network here, which is Genetic-Algorithm-optimised Back-Propagation neural network classification. I'll just pen it down for anyone who looks into it at any given point of time in near future. Okay, done. Where were we? Okay, so you are selecting the inputs for this particular stuff. Um, just seeing. Okay, fine. So you are selecting the inputs, and particularly selecting the inputs is identifying the grace level scale and the geometric features extracted from the defect region, then selecting the hidden layer size and the other functions that includes the activation function, then selecting outputs. So one node per wallpaper defect type. Then there is a GA, that is genetic algorithm space, which is created, which is particularly talking about encoding every trained weight and the bias of the BP network, which is back propagation network, into one long chromosome, which is real coded or binary in nature. Um, One chromosome itself is one complete neural network. I agree to disagree this, but this is what the this particular neural network talks about. Then we have the offline training, that is GA optimization loop, initializing a population of random chromosome, that is network. For every chromosome decoded, the weight, and then what we are running at the back end is the training set forward to compute the fitness level. Uh, for computing the fitness level, the equation which is utilized is 1 divided by classification error plus regularization term. Um, then we need to deploy the GA operators, that is genetic algorithmic operators, to select, crossover, mutate. At the selection process, we have examples like tournaments, roulets, and the alike. For the crossover, we have single point, uniform, and the like. Mutation, I would rather say random reset rather than talking about something which is already created right now. We take the best chromosome after the GA termination. The weight set is pre-trained network, and the deployment of the online inspection is to extract the same feature vector with the new wallpaper defect, feed forward through the GA optimized network. Output neuron with the highest activation is equal to the prediction of the defect class. Now, the good thing is for identifying the defect, nomenclature can be there, which is equivalent to the hue of the colors from the primary colors, not the secondary one. So we take the primary colors and we do the color coding around it, and that takes care of a lot of stuff, which can be a good input data to resolve the issues at hand. So we did this. I'll get back to this. For the okay. So we just talk about GAPA, GABP network. Then we have this. Hmm. So we're looking into the threshold determination stuff. So you already talked about we are evaluating the proportion of the pixel whose pixel value is less than the pixel threshold of the pre-processed image. So we are taking into account the variance between the classes, and obviously the probabilities of the pixels are assigned to the foreground and the background region respectively, and m is the weighing coefficient of the probabilities of the pixel. um, yeah, and okay, I like this. Let's see. So this is good enough for the pixel generation and stuff. So loads of pre-processed images are taken into consideration. However, I'm particularly of the opinion is how the variance itself can be changed taking into account a number of parameters also. So we'll look into it. I'll work on it for a while now and then see how it works. Thank you for watching this out, and have any questions, DM us. We'll look into it. Have a great day ahead.